Good afternoon. My name is Marilyn Stafford. I'm a science teacher. Welcome to mysciences.com. We're doing an experiment today, fluorescence versus incandescence, as far as which one creates the most heat, which one is the most energy efficient. We're going to test this so that we can see what kind of results we get and any kind of inconsistencies, looking at the standards for investigation and experimentation. We're going to take 2 beakers, and I have some tap water that is in them, and they're about approximately half full, and they've been sitting here for about 10-15 minutes at room temperature. And I'm going to take the temperature of both beakers, and I want to make sure that I don't mix up the thermometers once I use the thermometer for this beaker. And I will place the thermometer in here, give it a little bit of time to equilibrate, place it into the second one, give that a little bit of time to equilibrate. When I make my reading, I will make sure that the bulb isn't touching the bottom or the side of the beaker, because I do not want those inconsistencies. I want to be taking the temperature of the water, not the glass. And then once I know what the temperature is, I will write it down, and I'll label it as my fluorescent, because the light source I have right here is the fluorescent light source. And then on this one, same thing, I'll move the bulb up, take this temperature, and once I do that, I'll write it down under incandescent, and I'll remove the thermometer and put it over here. Then I'll go ahead and I'll turn on my light source, and I'll try to get the beakers as close as I can to this light source. And same thing with the fluorescent one over here. Okay, so what I want to, the incandescent light bulb right here works on electrical energy coming in, and there's a little tungsten filament, and it heats the tungsten filament and gives off a little bit of light. And as you'll notice, when we finish this, especially if you were just to even touch the outside of this lamp, it's quite hot and gives off a lot of heat. Whereas this curly, what we call curly, it's a CFL, it's a compact fluorescent light. This one has a little bit of mercury inside, and what happens is that the electrical energy that comes in excites the electrons in the mercury, moves them up to an energy level, and then as they come down to ground state, they emit a photon. And because it's not really in the visible range, then there's some fluorescence here, phosphorus here, and that will take that light and convert it to visible light so that we can see. And you'll notice when we get done, and I can even do that now, touch the outside of this lamp, and it's quite cool. But we're going to leave this here for about 15 minutes, and then at the end of 15 minutes, we're going to go ahead and take a reading again and figure out the difference in the water, temperature change in water, and see which one is the hottest, heats up the most, has the largest temperature change. Okay, so 15 minutes has passed, and I'm going to move this out, use the same thermometer I originally used, put it in here, give it a few minutes to equilibrate, make sure I'm not touching the bottom or the side, and I'll take the reading after I've waited a little while. And then the same thing over here. I'll move this out, and I'll put it in here, let it equilibrate for a moment, and I'll try not to touch the sides or the bottom again, and I'll take a reading. And we're done. You can go ahead and turn on the light. Ooh, that's warm. You can go ahead and dump the water. And you'll want to wipe down the countertops, make sure everything's turning off, leave unplugged. And now you're ready to do the calculation. We're not only going to calculate the difference in temperature as far as what had the higher changed the most as far as the temperature change, but also we have some energy efficiency that we're figuring out for each light bulb, and we got this information off of the packaging. That wraps it up for today. Thank you very much.